Welcome to this lecture. Here we'll be talking about the relationship between frequency, wavelength and velocity. So I will use the same diagram that we have seen before in the previous lecture. We have our wave or our sine wave, which is the displacement as function of time, and the wavelength, as you can see, the distance between the two successive peaks. And here we have something new called t, which is period. So this is the time required by the wave to complete one cycle. And the frequency is defined as 1 divided by t. And we will represent the velocity in this direction. So to understand the relationship between frequency, wavelength and velocity, the key to understand it is to use the motion relationship, which is velocity equals distance divided by time. So in our case, the distance is the wavelength and the time is the period t. So the relationship can be written as v equals lambda divided by t. And we have said that f is equals to 1 divided by t. So if we replace 1 over t by f, we obtain v equals lambda multiplied by f. And you can see here this pyramid. It may be helpful for you to remember the relationship. So if you are looking, for example, for the velocity, you can simply use the frequency multiplied by the wavelength. And if you are looking for lambda, which is the wavelength, you just have to divide the velocity by the frequency. And the same for the frequency, it's the velocity divided by the wavelength.